Hello, everyone. I will be talking about warming ocean temperatures using the case study of UAF's research vessel Sikuliaq. So, why is ocean warming occurring, and what is causing it? The vast majority of our planet's warming is taking place on the ocean. There's much more happening there than we can feel or notice on the surface, and that's because the ocean is soaking up all of the heat and storing it. Over 90% of the global heat is soaked up by our oceans. Water has a disproportionately high boiling point for its density compared to any other compound. This high boiling point means that it takes much more heat and energy to warm water than it does other materials. This is called water's heat capacity. So water can consume and store a vast amount of energy, which is what heat is to our sensory systems, before it begins to put that energy back out into the system. When water heats up, before it reaches its boiling point, the molecules begin to expand. They spread out and begin moving faster. Their electrical conductivity is altered by the physical change and energy transfer. Our sea levels are rising not only because we have more liquid water in the system than we ever have, due to melting ice sheets, but also because the liquid water that is already there is physically expanding in direct relation to the energy put into it. And we have put a lot in. This process, called thermal expansion, is estimated by NASA to be responsible for up to half of the global sea level rise. But how is the water absorbing over 90% of our energy if the majority of the world's operations take place on land? The emission of greenhouse gases and other heat trappers emits CO2 into the atmosphere. The CO2 then reflects the heat back towards the Earth. Our oceans cover over 2/3 of our planet, so the heat waves are easily absorbed by having a majority presence. Here's a phase diagram of water. It shows how water has a negative slope, implying that its liquid form is denser than its solid. It also shows the disproportionately high boiling point in relation to density, as well as suggesting the presence of a potential fourth phase, in which the H2O is physically akin to ice but retains its liquid state. This has some very cool implications for ice and water mechanics, but now is unfortunately not the time to talk about it. So where is ocean warming occurring in Alaska and the Arctic? While the entirety of the ocean is warming, and that includes all of the ocean in Alaska and the Arctic, there are places in which warming is occurring more rapidly than others. The surface of the water, down to about 700 meters, is warming the fastest, with the first 75 meters on the very surface warming at an even faster rate of about 0.6 Celsius in the last 50 years. The Arctic as a whole is also warming 4 times faster than the rest of the planet, and this is feeding into the Northern Ocean's warming by way of warmer air temperatures, melting glaciers, and marine heat waves. Regions that have traditionally experienced a consistent ice cover pattern and have retained a high albedo are experiencing an exponential decrease in this albedo, and the sea surface temperature is an essential part of this. When the surface temperature rises, this increases the melting of the sea ice and the glaciers feeding into the oceans. This, in turn, decreases the area's albedo, allowing more IR waves to penetrate into the seawater, warming the water more, and looping back into melting more ice. This is a photo that I'm sure we have all seen at some point, illustrating the drastic warming happening in the Arctic in relation to the rest of the world. How is ocean warming affecting the social ecological system? I found this part the most difficult to talk about because it is so complex. There are a potentially infinite number of ways that ocean warming is affecting our social ecological systems that would take up far more time than I have left to cover. So I've decided to focus mainly on the social ecological system within the case study that I've included in this presentation. However, I have provided brief examples of others here. Crabbing season has been closed the past 2 seasons. Some of the crabs have gone to colder waters, but it's thought that most likely the crabs have cannibalized each other and starved to death in the high temperature water. The second example is that a toxic algae has come up from southern waters as the Alaskan waters warm. It's a neurotoxin, and when consumed by wildlife, causes them to lose their ability to feed, and they eventually starve to death. It's toxic to humans who consume this wildlife, and hunting seasons in the past have been limited or canceled because of safety concerns. What feedback loops is ocean warming influencing in the system? Perhaps the most important feedback loop that rising ocean temperature is affecting in the system is the ice albedo feedback. Albedo is the ability of a surface to reflect sunlight, and ice has a very high albedo. When the sea surface temperatures rise, the warmer water increases the melting of sea ice and glaciers. With the decrease in surface ice comes a decrease in surface area that is able to reflect the sun's IR waves back into the atmosphere. This means that there is more heat being soaked up by the ocean, warming the ocean and, in turn, melting more ice. Here's a friendly photo illustrating the damaging effect of declining albedo in the Arctic. This is the case study of RV Sikuliaq, UAF's research vessel. Sikuliaq was built specifically to sail in Arctic seawater conditions as well as to be able to break through first-year sea ice. Sikuliaq is the only vessel in the UNO's research fleet that is ice-capable, so she is a very important part of water-based Arctic research. The engineering on Sikuliaq is specific to cold water systems, and, as the water warms, the crew on Sikuliaq have noticed rising complications in her operations. The engines run on a special evaporation system designed for extreme cold weather climates. As the water's warm, the engines need more water pumped through them to not overheat. This increase in pumping leads to an increase in clogs, because the water is pumped from the ocean. When the engines clog, it requires a full engine shutdown, and acid needs to be run through the system. This delays the science teams and increases operational risks for the crew. The steering system also runs on this evaporation system, and when it overheats, the ship runs risks of not steering properly and blowing out the system. The oil used in Sikuliaq's engines is also cold water specific, and as the water's warm, the engine oil becomes much thinner. It doesn't cover the systems as well, and, similar to a car engine, can render it inoperable. Actions to adapt. The most interesting one that I found is OTEC, Ocean Thermal Energy Conversion. This was originally developed as a way for island communities to have consistent electricity and clean water. OTEC uses warm surface seawater and converts it to clean energy. While it was not developed for and has not been used as a direct mitigation solution for warming ocean temperatures, it is an adaptation and technology that we already have that has a lot of potential for the future. The second action is the Arctic Ice Project, formerly known as ICE 911. This group is focused on efforts aimed at cryosphere retention. They cover ice sheets with silicone beads that mimic the natural reflection of the ice sheets and give the ice more time to reform instead of taking on all of the sunlight and melting. And finally, our Ocean Conference. Our Ocean Conference brings together leaders from across the world and focuses on solutions to the largest problems facing the ocean. They usually pick about 5 topics that are judged to be the biggest problems and spend the time coming up with solutions to each of them. That's all. Thank you.